We are now ready to use what we have observed to develop a formal probability model to describe the behavior of sample proportions. First, let's return to the original question that prompted our investigation of sample proportions. We based our investigation on the prediction that 60% of part-time college students will be female. In our investigation, we asked, how much could the sample proportion vary from a population proportion of 0.60 for us to feel confident in our prediction? We don't expect the sample proportion to be exactly equal to the population proportion, but how much error seems reasonable? We now see that the answer to this question depends on the size of our sample. If we select a random sample of 25 students, the distribution of sample proportions has a standard deviation of about 0.10. We can see that most sample proportions fall within two standard deviations of 0.60. Therefore, we might decide that 2 multiplied by 0.10, which is the standard deviation, 0.20, is a reasonable margin of error. So a sample proportion between 0.40 and 0.80, which is our the 0.60, the original, minus 2 times the standard deviation and plus 2 times the standard deviation. Minus would be 0.40, plus would be 0.80, is not surprising if 0.60 of all part-time college students are female. Also, if we select a random sample of 100 students, the distribution of sample proportions has less variability, a higher number of students. Our sample is a higher number. It has a standard deviation of about 0.05. Again, we see that most sample proportions fall within 2 standard deviations of 0.60. So we might decide that 2 times 0.05, which is 0.10, is a reasonable amount of error for these large samples. For a sample of 100 students, then, a sample proportion between 0.50 and 0.70 is not surprising if 0.60 of all part-time college students are female. So notice the first random sample size was 25 students, and we took 0.60, which is represented the 60%, the actual 60% of college students. We added 0.2, which was 2 times the standard deviation, and subtracted 0.2. So we expected all the values of our random samples to be between 0.40 and 0.80. But once we increased the number of students in our samples to 100, then we actually took that actual proportion, 0.60, and we added only 0.10. So we could be more sure, I guess, is what's going on here. Instead of adding or subtracting 2 times the standard deviation, we only have to add or subtract 0.1. So the larger your sample size, the more closely your random sample should reflect the actual average.